Alrighty folks, in today's video we're going to look at how we graph and sketch these polynomials given specific equations. So the first thing we're going to do is look at our n-run behavior. To compute our n-run behavior, we take a look at our total power. In this case, this is a third power or cubic polynomial. We know that because we've got this 2, we've got that invisible 1 there. 1 plus 2 is 3, giving it a third power polynomial. We also look at the coefficient. On this x, we've got a positive sign. Outside this parentheses, we have a positive sign. So we have a positive coefficient overall. As far as those shapes we covered in class, we would say this is an on-tempo dancer because our x's and y's are going in the same direction. As x goes to positive infinity, y will also go to positive infinity. As x goes to negative infinity, y will also go to negative infinity. Zeros. I have 2 zeros, 1 for each term. My first 0 occurs at x equals 0. My second one occurs at x equals negative 2. I get these by looking at each individual term and saying them equal to 0. I then isolate my x value. Multiplicity. I look at my exponents for this. Exponent of 1, that's an odd exponent. So at x equals 0, I'm going to have a cross occurring. At x equals negative 2, I have a 2, a squared exponent. That's an even number, so I'm going to have a bounce. My y-intercept, plug in a 0 for my x values, and solve. I'll end up with a y-intercept at 0, 0. I can now take this information and go to my graph to sketch out my bit. So I know that I'm going to have x to positive infinity, y to positive infinity. So I'm going to be dealing with this quadrant up here, quadrant 1, and x to negative infinity, y to negative infinity, this quadrant down here in quadrant 3. I know that I'm going to have a 0 at x equals negative 2, and a 0 at x equals 0. My y-intercept is 0, 0, and at x equals 0, I'm going to cross my boundaries. At x equals minus 2, I'm going to bounce back from my boundary. So I'm going to use this to sketch my graph, starting from my quadrant 3, going up towards my first 0. At that first 0, I have a bounce. It bounces back, goes to the next 0. I have a cross. It crosses over. Now this is a sketch, so I don't know if this little hump here is deep enough, shallow enough, exactly right, shifted left, right. We're going for a general sketch. Now because this is a general sketch, that means we can't actually solve for increasing or decreasing intervals, and that's okay. My domain, all polynomials have a domain of negative infinity to positive infinity. My range, because this is a cubic, or rather an odd-powered polynomial, I know my range is going to be negative infinity to positive infinity. Moving on to the next one. Once more, we have ourselves a third power polynomial. So another cubic, because my exponents are 1, 1, and 1. And all of my coefficients are positive. So once more, we're going to have our on-tempo dancer, that kind of shape, such that our x's go to positive infinity, our y's will also go to positive infinity. And as our x's go to negative infinity, so too will our y's go to negative infinity. Zeros, we have 3 zeros. We're going to set each of our terms here equal to 0 and solve them out, or use our x's lie rule. This gives me zeros at x equals negative 1, x equals 2, and x equals negative 4. Now note, folks, these are not in increasing to decreasing order, or vice versa. It doesn't matter what order we put them in necessarily, just be mindful of the orders when we actually go to sketching them. Multiplicity. At the x equals -1, we're going to have a cross because of that one exponent. At x equals 2, we're going to have another cross because once more we have that odd exponent. And at x equals -4, we're going to have yet another cross. So once more, we've got that odd exponent. My y-intercept, replace my x's with zeros, and I have 1 times -2 times a +4, which gives me a y-intercept of 0, -8. I'm going to take all this information to sketch out my graph. So I know I've got a 0 at x equals -1, another one at -4, and one at x equals 2. I know that I have a y-intercept at 0, -8. And I know that I'm going to start down here in my third quadrant and end up here in my first quadrant. So now let's connect some dots. As I approach the first 0, x equals -4, I'm going to cross over as per my multiplicity. Approach my second 0, cross over once more. Now before I can get to my third 0, I have to go through my y-intercept. So hook this down, cross over, come back up, and cross over. To give us our general on-tempo dancer. Once more, we can't actually solve for increasing or decreasing because this is a sketch. We don't know necessarily if this hump or that hump are truly accurate. We only know the behaviors at these zeros and as x goes to positive and negative infinity. However, because we know what happens as x goes to positive and negative infinity, we can solve for our domain of negative infinity to positive infinity, and our range, because this is a odd powered polynomial, will run from negative infinity to positive infinity. All right. So f of x is equal to x squared times x minus 3 times x plus 4. First things first, take a look at our end run behavior. Our powers, we've got an x squared, x minus 1 to the first power, x plus 4 to the first power. This is a fourth power, or quartic, not quadratic, but quartic polynomial. The coefficient overall is positive, which means shape-wise, we're looking at that smiley face, such that as x goes to positive or negative infinity, y will go to positive infinity every time. Zeros, we have 3 zeros. We have zeros at x equals 0, x equals 3, and x equals -4. Multiplicity, we're going to have a mix of them. At x equals 0, we've got this even exponent, so we're going to have a bounce. At x equals 3, we've got the odd exponent, so we're going to have a cross. And at x equals -4, we've got that odd exponent, so we're going to have another cross. Now once more, folks, notice that our zeros are not in ascending order. This will be important when we go to graph things out. My y-intercept, plug in a 0 for all of my x's, and I'll end up with a y-intercept at 0, 0. In general, anytime we have an x out front, or rather an x that's by itself, no plus anything, no minus anything, our y-intercept will always be a 0, 0. So take this information, head over to our sketch. I know that my end behavior says we're going to start in quadrant 2 and go on to quadrant 1. I know I have zeros at x equals -4, x equals 0, and x equals 3. I know my y-intercept is 0, 0. So at this point, I can start making my sketch by connecting my dots. Starting quadrant 2, I'm going to come down to my x equals -4. And based on multiplicity, that means I'm going to cross over. I'm then going to go to my next 0 at the origin point. At that point, my multiplicity says I'm going to bounce, so I bounce back down. Lastly, my last 0 is x equals 3. Hit there, cross over, to give me my general shape. Because this is a sketch, I don't know my increasing or decreasing intervals. I can find my domain, though. My domain is -infinity, positive infinity, as it is with all polynomials. My range I can't actually solve. Why can't I solve that? Well, I know that I'm starting in quadrant 2, and I know that I'm ending in quadrant 1. I know that my zeros are at -4, 0, and 3, and I know what behavior happens at each one, a cross, a bounce, and a cross. But there's nothing here that gives me immediate information as to what happens down here. I don't know if these humps here are of accurate shaping, distance, too shallow, shifted left, shifted right, too deep. I don't know. So I cannot accurately say what my range is because I don't know how far down we actually go here in quadrants 3 and quadrants 4. All right, last one. Start off with our powers. I've got a 2 and a 2. So I've got 4 power overall, which makes this another quartic. My coefficients are both positive, so I've got another smiley face going here. So as x goes to positive or negative infinity, y will go to positive infinity. My zeros, I have 2 zeros. I have a 0 at x equals -2, and a 0 at x equals +4. Multiplicity. Multiplicity, again, look at my exponents. At x equals -2, I've got an even exponent. So I'm going to have a bounce. At x equals +4, I have another even exponent. I'm going to have another bounce. So both my multiplicities will bounce. Y-intercept, plug in a 0 for my x value, I'll end up with 64. Positive 64, because this will be 2 squared, which gives me 4. This will be -4 squared, which gives me 16. 4 times 16 is 64. Take this information and graph it representatively. So I know that I'm going to have quadrant 2, different color. I know I'm going to have my quadrant 2 and my quadrant 1 being of importance. I know that I have a 0 at x equals -2 and x equals +4. I know my y-intercept is at 0, 64. Now, that 64 is a little higher than what we've been doing so far, but we can still represent it. We will represent it by having our y-axis be of a different height, not by 1s, not by 2s or 5s, but rather we're going to count by 10s. So 10, 20, 30, 40, 50, 60, 70. So somewhere between our 60 and our 70 will be our 0, 64. At this point, connect our dots. Approaching our first 0, at x equals -2, we're going to bounce. We'll bounce up to cross our y-intercept, come down to hit our x equals 4, and bounce back based on multiplicities. Give us our general shape. Now once more, my increasing and decreasing interval I cannot solve. But I can actually solve now my domain and my range. My domain, as all polynomials will be negative infinity to positive infinity. All my range will be 0 to infinity, with a bracket on that 0. The reason I know that is because I know what happens when we get to these zeros. Our graph will touch the 0, then bounce back, meaning that y equals 0, whether at x equals negative 2 or x equals positive 4. The y value is 0. That is the lowest possible y value, giving us a range of 0 to positive infinity. And that, folks, completes the notes here on sketching polynomials. If you have questions, please shoot me an email, ask questions in class, come to Flex, or come to tutoring.